These are the step-by-step answers for the Calculus BC Practice Final 4. Let's get started. The function f is twice differentiable for x is greater than 0, with f of 1 is equal to 15 and f double prime of 1 is 20. Values of f prime, the derivative of f, are given for selected values of x in the table above. Write an equation line for the tangent of the graph of f at x equals 1. Use this line to approximate f of 1.4. So here we go. So at x equals 1, we have our point. So at x equals 1, we have 15 given. And f prime of 1, which is going to be 8. So we can just set this up and turn it into a y equals mx plus b problem. I want to set this up in point slope form, so it's going to be y minus 15 is equal to 8x minus 1. So basically I derived it from this formula. And then now I'm going to add 15. Y equals 8x minus 8 plus 15, which we're left with y equals 8x plus 7. So now what I did first was find point and slope. Or derivative, whatever you like to call it. Plug and chug into point slope and converted to slope intercept. Now we're going to use that tangent line to approximate f of 1.4. So f of 1.4 is equal to 8 times 1.4 plus 7. 8 times 1.4 is 3.2. 7 is equal to, no, 8 times 14, that's not 3.2. 8 times 1.4 is going to be 11.2. And then you add that by 7, which gives you 18.2. So for this one, plug in 1.4 to there you go. Use a midpoint Riemann to approximate 1 to 1/4 f prime of x dx. Use this approximation to estimate f of 1.4. Alright, so let's see. 1 to 1.4 is equal to we're going to use a midpoint Riemann, so 1 to 1.4, 2 subintervals, so we're going to use this 3 and this 3. So midpoint formula, or midpoint sum formula is middle point value of x, so it's going to be middle point value of x times the distance from left to right, so it's right minus left point. Alright, that's the formula. So it's going to be, our midpoint is at 1.1, so it's going to be 10 times the distance from 1 to 1.2, which is going to be 0.2. Plus, what's our midpoint for the second interval? 1.13 times 1.2 to 1.4 is going to be another 0.2. So now we're going to combine those. It's going to be 2.0 plus 2.6, and you should get 4.6 here. Now to approximate f of 1.4, it's going to be this. So from 1 to... We're going to use the candidates formula. Oh, let's write down the steps here first. 1. So let's approximate f of 1.4. F of 1.4 is equal to f of 0 plus 0 to 1.4 f prime of x dx. And f of 0... No, f of 1, sorry. Because we're given that integral. So f of 1 is equal to 15. Oh, don't forget, apply candidates formula. Let me write down the formula again, but I did write it down in the previous video, so if you remember it, you can skip 10 seconds. So it's going to be 15 plus whatever we got here, which was 4.6, and you should get 19.6 as your answer. Ta-da! Using Euler's method starting at x equals 1 with 2 steps of equal size to approximate 1.4, show the computations that leads to your answer. So your first step is calculate step size. So we're going to step size equals f of destination. So it's going to be destination or approximate minus origin over step number. Alright, so it's going to be equal to 2. Approximate is 1.4 minus 1. So you're left with 0.4 divided by 2, which I believe you get 0.2. So your step size is 0.2. Okay? So we start at x1 and we take a 0.2 step size. So we're at 1.2. F of 1.2 is given by f of 1, which is going to be 15 time plus dy dx times your step size, which is 0.2. So your Euler formula is gonna be y new equals y old plus dy dx times step size. So it's gonna be f of 1.2 is rounded to 15 plus dy dx at x equals 1. So what is f prime of 1? That's going to be 8. So it's going to be 15 plus 1.6, which is equal to 16.6. So it's going to be 1.2 comma 16.6 as your first approximation. So this is going to be your new x old and y old. So we stop at f of 1.2 and we take another 0.2 step size. So now it's going to be f of 1.4 is approximately f of 1.2 plus dy dx at 1.2 times your step size, which is 0.2. So f of 1.2, f of 1.2 is going to be 16.6 plus dy dx at 1.2 is going to be 12 times 0.2, which is going to be 2.4. So 16.6 plus 2.4, you're going to be left with 19. And that is your approximation. So 1, apply, that's 2. Apply Euler's formula and use data values. 3, plug and chug, as always. Moving on to part D, write the second degree Taylor polynomial for about x is equal to 1. And we're going to use that to approximate f of 1.4. The Taylor series, we're given x equals 1 is going to be fn of x is x minus c to the n over n factorial. So we're going to round it to the second degree. So let's see. F of 1 times x minus 1 to the 0 over 0 factorial. These do nothing. Plus f prime of 1 times x minus 1 to the first power, 1 factorial. That does nothing as well. F double prime of 1 times x minus 1 squared over 2 factorial, which is going to be 2. Now let's evaluate that. F of 1 is going to be 15. F prime of 1 is going to be 8. And f double prime of 1 is going to be 20. And divide that by 2, you're going to be left with 10. And that is your second degree Taylor polynomial for about x is equal to 1. We're going to approximate f. That's f of x, by the way. We're going to evaluate that at 1.4. So f of 1.4 is equal to, 1, apply Taylor series. 2, plug and chug. So f of 1.4 is going to be 15 plus 8 times 1.4 minus 1 plus 10, 1.4 minus 1 squared. So it's going to be 15 plus 0.4 plus 0.4 squared is going to be 0.16. So it's going to be 15 plus 3.2 plus 1.6. So you're left with 19.8 as your answer. So first step, and your only step, is plug and chug. All right. Moving on to question 2, which has 4 parts. So we have 8 questions left. Ooh. Okay. This is going to be a tougher set. The graph of the differentiable function. This has so much information. So let's see. Find the average value of f on the interval. So from 0 to 5, this is basically it, right? Because average value is given by this formula. That's the average formula. And now, from 0 to 5, let's find our areas. So, the area of the region from 0 to 5 is going to be -10. And from 5 to 10 is going to be 27. So from 0 to 5, our area is going to be -10, and 5 minus 0 is going to be 5. So it's going to be -2 is our answer. So first step, apply perfect. B, evaluate from 0 to 10, 3 f of x plus 2. Show your computations. I want to split this up. So it's going to be 3 from 0 to 10 f of x plus 0 to 10 f of x. Sorry. 2. So from 0 to 10 of f of x, what is our area? It's going to be 17. Plus 20, because the antiderivative of 2 is going to be 2x. We're going to do it by 2 times 10, which gives us 20. So 3 times 17 is going to be 51 plus 20, which gives you 71 as your answer. So pretty easy. Split integral. What else did I do? Integrate and algebraically solve. All right. Moving on to C and D. Let g of x equal from 5 to x, I'm assuming. That is blurry. Let me look at the answer key. It is 5 to x. F prime of f of t dt. On what intervals is the graph of g both concave up and decreasing? So, and if g is concave up, g double prime of x is greater than 0, and g prime of x is less than 0. So first step, identify vocab. And then 2 is match criteria. So g prime of x, so let's see the comparison. G prime of x is equal to f of x, and g double prime of x is equal to f prime of x. So we're going to look for when f of x is less than 0, so it is below the x-axis, and when f prime of x is increasing. So let's use that function above. The criteria says when is f prime of x, when is the slope positive, when is f prime of x greater than 0? So when is the slope positive? Slopes are positive here. And when is it decreasing? So f prime of x must be positive, and f of x must be below 0, decreasing. So it's got to be below the x-axis. So this is the only area that's beneath. So in this part, the graph is concave up and decreasing. So let's put the justification. So what interval is that again? I forgot. 3 to 5. G is concave up. Do not abbreviate on the AP test. I'm just abbreviating for reference. And decreasing from 3 to 5. Because f prime is greater than 0 and f is less than 0 on this interval. Alright. Ta-da! D. The function h is defined by this. The derivative is this. Find the arc length of y equals h of x from 0 to 20. So arc length is going to be equal to 0 to 20, 1 plus dy dx squared dx. That's the formula. So dy dx here is f prime of x over 2. So from 0 to 20, it's going to be 1 plus f prime of x over 2 squared dx. So let's look at this. U equals, let's use a U sub. So first, identify arc length formula. Two, plug in dy dx and U sub. Alright, so U equals x over 2, du equals 1/2 dx. Remember that you want your constants on the left, so it's going to be 2 du equals dx, and we're going to change our limits. So u upper limit is going to be 20 divided by 2, which is going to be 10, and u lower limit is going to be 0 over 2, which is 0. So 0 to 10, 1 plus f prime of u squared du. 2. So, from 0 to 10, or let's look at the criteria again. From the arc length from 0 to 5 is going to be 11, and the arc length from 5 to 10 is going to be 18. So we're going to add those arc lengths together. So it's going to be 11 plus 18. Which you're left with 2 times 29. So it's going to be 58. So 3 use scenario for data, and I got 50 as my answer. All right, last question. 3, let f of x equals sine of x squared plus cosine of x, and the graph of y 5 of x is shown above. So now we're going to have to find the first non-zero terms for sine of x and rewrite the first non-zero terms for sine of x squared. Okay, so this is a power expansion. You guys should memorize this. So it's asking for 4 terms. So just write until here. Sine of x is equal to x minus x cubed over 3 factorial plus x over 5, x to the power 5 over 5 factorial minus x to the 7 over 7 factorial. So we already got the first part down. Let's do sine of x squared. So now it's going to be boop boop squared minus boop boop squared over 3 factorial plus boop 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 5 factorial minus boop 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 over 7 factorial. So now we're going to replace it with x, x cubed, x fifth, and x to the 7th. Properties of exponents says that these exponents multiply, so it's going to equal to x squared minus x sixth over 3 factorial plus x to the 10 over 5 factorial minus x to the 14th over 7 factorial. So ta-da, this is the power expansion. So that's pretty much it for part A. What I did first was list sine power series, then 2 squared all x values. Alright, write the first non-zero terms for cosine of x. So cosine of x, memorize this, is going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Alright, now we already finished the first part of this problem. Now we're trying to use this series and the series of sine of x squared to write the 4 non-zero terms of f for about x equals 0. So we're going to add this together. And it's going to take quite a bit of algebra. Well, it's a little bit of math to work. So let's get started. Sine of x squared. Let's look for any common values. So we have, let's use the least values first. So it's going to be 1 minus x squared over 2. And we're going to add that by x squared because we're going to use the other one. Plus x4 over 4 factorial minus x to the 6th over 3 factorial minus x to the 6th over 6 factorial. So we're going to leave the 1 alone. 1/2 x squared plus x squared is going to be left with 1/2 x squared plus x4 to the 4 factorial. 4 factorial is going to be 24. And we're going to simplify this. This is going to be 3 times 2, which is going to be x to the 6th over 6 minus x to the 6th over 720. Because 6 factorial is 720. So we're going to multiply the top and the bottom by 120 over 120, which is equal to negative 120 x6 over 720 minus 1x6 over 720, which gives you negative 121 x6 over 720. And boom, that is your new expansion when combined sine and cosine. So 1, list cosine power series. 2, combined first for least, keep that in mind, non-zero terms of sine x squared and cosine power series. All right. last two questions. Find the value of, f of 6 of 0. So remember that we're going to apply this Taylor formula here. So it's going to be f of 6 of 0 times x to the 6th over 6 factorial, but in reality 6 factorial is just going to be 720. And from looking at our previous question, that value, the 6th Taylor degree polynomial, is negative 121 over 720 x to the 6th. And you want to find f, we just want to find this only, so we're going to have to isolate that. So we're gonna multiply by the reciprocal, so it's gonna be multiplied by 720 over x to the 6th. Those two cancel out, and that other 2 cancels out. So we're gonna do the same thing here. 720 over x to the 6th. Same thing happens here. Cancel party right here, and we're left with f of 6 of 0 equals negative 121. Ta-da! One list Taylor formula applied previous answer and what I did now is set f of 6 of 0 isolated. Last question. This is probably one of the hardest questions since we all fell asleep during the lecture. Find this Lagrange error. But if we use this function, our f of x, we noticed that that series was not alternating. So we have to use something called Lagrange's theorem. It's going to be maximum times x to the 5th, since we're dealing with the 5th Taylor polynomial, over, 5 factorial. So that's going to be, we're going to find the maximum value of our graph, at x equals 1/4. This is going to be x equals 1/4 because it's measured in 4 intervals. 1/4, 1/2, 3/4, and 1. 1/4, the maximum is approximately 40. We're always approximating here. So this is an error sum, so it doesn't have to be precise. So our max is going to be 40. So 40, pen activate. All right, 40 times 1/5. Wait, is it 1/5? No, 1/4 to the 5th over 5 factorial. I believe 5 factorial is 5 times 4 is 20. 20 times 3 is 60. 60 times 3 is 120. It's going to be 1. And we can simplify that, which is equal to 1/3 times 1/4 to the 5th, which is equal to 1/3 times, I believe, 1 to the 4 to the 5th power. Let's calculate that. 4 times 4 times 4 times 4 times 4, 16. 16 times 4 times 4 times 4. 16 times 4 is 64. 64 times 4 is 256. And 256 times 4, let's calculate that. 256 times 4, 6 times 4 is 24. 4 times 5 is 20. 20 plus 2 is 22. 4 times 2 is 8 plus 2 is 10. 10, 24. And we're going to have to prove that this approximation is less than 1 over 3,000. So 1/3 times 1 over 1,024 is 1 over 3,000. 3 times 1, let's multiply that. 4 times 3 is 12. 3 times 2 is 6, plus 1 is 7. 3 times 0 is 3,072. So is that less than 1 over 3,000? Yes, because 1 over a bigger number than 1 over a smaller number, 1 over a bigger number is going to give you a smaller number, and 1 over a smaller number is going to give you a bigger number. So let's say that we have 1/4 is less than 1/2. That is true, because 1/4 is 0.25 and 1/2 is 0.5. So that kind of applies to this thing here. It's pretty easy-ish. All you just have to do is confirm that this answer is correct. And this concludes the final part of the Calculus BC Part 4 final FRQ. No calculator. Good luck.